Welcome to the Dual Chamber Bioreactor tour. Our research site is located at the Conservation Showcase. This is about 20 miles southwest of Iowa State University. The bioreactor itself is right along Big Creek. This is a great site for field tours because we've got a number of conservation practices that are out here at the same site. There's a reconstructed oxbow, pollinator habitat, and saturated buffer, just to name a few. Today we are going to go over some of the details about the design of the dual chamber bioreactor and show you some of our sampling procedures. So we're going to show you a number of the features of the bioreactor. We've got a main inlet here. If you travel along, you can see here is bioreactor or chamber A. You can see in green closest to us here we've got the inlet, and there are a number of sampling wells along the length of the bioreactor. And at the other end you can see a red flag. Let's see if I can zoom in on that. Is the outlet.
I am at the main inlet of the dual chamber bioreactor, and in here is what controls the amount of flow that goes into chamber A and chamber B.
Okay, I'm going to come on in close and look in there.
On this side right here is what goes into the bioreactor, and if there's enough flow, it will flow over this V-notch weir here and go out and bypass into the stream instead.
This is the discharge end for the inlet going into Big Creek. The black pipe is the bypass flow from the main inlet, and that steel pipe is the extra drainage from the 16-inch main tile line that is not feeding the bioreactors right now.
Here I'm at the inlet to chamber B, and this controls the amount of flow that goes into chamber B from the main inlet.
And then I'm zooming in to show the water flow into the inlet of chamber B.
I'm at the first well of chamber B bioreactor. Underground is the pit of wood chips that is the bioreactor, and in here we have sampling wells. These are slotted PVCs that allow the water to go through but keep the wood chips out of our sampling wells for us. As part of our sampling procedure, we measure dissolved oxygen and the temperature in the wells. So we have that going right now. This one is at 0.47 milligrams per liter of dissolved oxygen, which is optimal for bioreactors to remove nitrate. Our temperature is 15.9 degrees Celsius. The warmer it is, the faster the nitrate is removed from the bioreactors, as that again makes it a more optimal condition for the denitrifying bacteria. Besides measuring dissolved oxygen, we also measure the water level in these bioreactors, which is what I have here. As it beeps, that means that the tape measure is in the water, and we can pull it out till it stops. Today there is about 6.83 feet of water until we reach the water in this well. Here I'm at another one of the wells. Again, as part of our sampling procedure, we pump the wells out for a few minutes to make sure we are having and collecting a fresh and accurate sample. And after those couple minutes have elapsed, then we use this pump and we collect our sample from in the wells to know what the nitrate level is throughout the bioreactor length. Here I'm holding some wood chip bags. These were taken outside of the well. They are normally located in the well except when we are sampling. We keep these wood chip bags in there for us to do analysis later on to see how the wood chips are breaking down at different depths in the well, as well as looking at the type of bacteria that's present in the wood chips. Now I'm at the outlet of chamber B. This here is attached to a pressure transducer down there. This is vented to account for the atmospheric pressure, so then we know the pressure that is going over the V-notch, and we can convert that into a flow rate that is leaving the bioreactor. We have one of these located in the outlet of chamber A as well as the main inlet to know the flow into and out of the bioreactor at all points. We measure dissolved oxygen, temperature, and water level at the outlets as well. And then when we collect the sample at the outlet, we will attach a bottle onto a pole to sample, and then we simply put it down in here to collect the flow over the V-notch into the bottle.
Okay, so this is outlet B. You can get a closer look of the pressure transducer down in there. It sits under the water, so it can give you a measurement of the water level going over that V-notch there. Right, and this is where the outlet discharges into Big Creek. Both bioreactor chambers route into this main tile and discharge here at the creek.